to first solve the previous problems that we had from last session, and then we will talk about scientific notation. The first problem: helium has the lowest boiling point of all the elements at 452 degrees Fahrenheit. Convert this temperature to degrees Celsius. It's enough to write only the formula which can convert these two temperatures to each other. Degrees Fahrenheit minus 32 degrees Fahrenheit, again multiply 5 degrees Celsius to 9 degrees Fahrenheit. By substitution of 452 degrees Fahrenheit, here we can get the answer, which is minus 269 degrees Celsius. Easily we converted the degrees Fahrenheit here to degrees Celsius. Let's go to the second problem. Mercury, the only metal that exists as a liquid at room temperature, melts at minus 38.9 degrees Celsius. Convert its melting point to kelvins. Okay, first I will write the related formula which can do that for me. Degrees Celsius plus 273.50 degrees Celsius. It's enough in exams if you memorize these formulas, or maybe if it's open book, the exam, so you can use it easily. It's not necessary again for some of you to memorize it. By substitution of this amount in the formula, I can find the Kelvin, 234.3 in Kelvin. Let me write it here. Okay, let's go to our lesson, which is scientific notation. First, chemists often deal with numbers that are either extremely large or extremely small. For example, in 1 gram of the element hydrogen, there are roughly these amounts of hydrogen atoms. Each hydrogen atom has a mass. Each hydrogen atom has a mass of only this amount. These numbers that here you can see are cumbersome to handle, and it is easy to make mistakes when using them in arithmetic computations. Consider even the following multiplication. Come on. It would be easy for us to miss even 1 zero or add 1 more zero after the decimal point. Consequently, when working with very large and very small numbers, we use a system called scientific notation. Regardless of their magnitude, all numbers can be expressed in a form of n multiplied by 10 to exponent n, where n is a number between 1 and 10 and n small. The exponent is a positive or negative integer whole number. Any number expressed in this way is said to be written in scientific notation. Well, let's have some examples. The first one: express this number in a scientific notation. Here, okay, I will first solve the first one. If we want to express it in this way, first I will write it like, let's keep my pen constant, n multiply by 10 to exponent n. I only move the decimal point 2 units to the left and write it like that, 68. And the remaining numbers multiply 10 to 2. Note that the decimal point is moved to left by 2 places and n is 2. It's not negative, it's positive. When we move the decimal point to the left, the final n number is positive. While in this example that we want to express it in scientific notation, I want to move the decimal point to the right, and I will write it. So again, this formula that we have, and I will count 1, 2, 3, 4, 5, 6. So I should place the decimal point after the first 7 and write it like that, 7.72 multiplied by 10 to minus 6. Here the decimal point is moved to the right by 6 places and n is minus 6. Here are some points that is interesting to be considered. When n equal to 0, it is used for numbers that are not expressed in scientific notation. For example, this number is equivalent to 74.6. So when 10 has the exponent of 0, it is always considered to 1. And that's why we don't mention it. Here, when n is equal to 1, the usual practice is to omit the superscript when it is equal to 1. For example, the scientific notation for 74.6 is its multiplication by 10 and not this one by 10 to exponent 1. We will omit that one. In some calculations, how we write the results like scientific notation. Consider addition and subtraction. To add or subtract using scientific notation, we first write each quantity. Say these quantities are like n1 and n2 with the same exponents. Then we combine n1 and n2. The exponents remain the same. Consider the following examples. 7.4 multiply 10 to exponent 3 plus 2.1 multiply 10 by exponent again 3. As you can see, the exponents are equal. So it's enough that we sum these numbers together and write one of these exponents, which the result is 9.5 multiplied by 10, 3. But however, we can have some examples in which the exponents are not equal and we need for addition and subtraction to make them equal. For example, consider the following problem. 4.31 multiply 10 to 4 plus 3.9 multiply 10 to 3. As you can see, the exponents here are not equal, and for do this calculation, which is addition, we need to make them equal. So I will start with this one and try to make its exponent like that one. So I have learned if I move this exponent to the left, the number of n would be positive. So 1 positive would be added to 3. Let's do that. So I will move this decimal point one number to the left. It would be 0.39 multiplied by 10 to 4. One positive was added to this exponent, and now the exponents both are equal. So the final answer in this case would be 4.70 multiplied 10 to 4. For subtraction, we have the same situation. Let's do for the multiplication. To multiply numbers expressed in scientific notation, we multiply again the same n1 and n2 in the usual way, but add the exponents together. What does it mean? So in multiplication and even division, that I will show you in the next slide, it's not necessary that the exponents be equal. So because we will add them. How? Consider the following example. 8 multiplied 10 exponent 4 multiply 5 to 10 exponent 2. However, here you can see that the exponents are not equal, and it's not necessary to make them equal because we add them. So the result is 8 multiply 5 multiply 10, and the exponent would be added to each other. And the final result is 40 multiply 6, and if we want to write it with scientific notation, which is 4 multiplied by 10 to 6. Another example is 4 multiply 10 to minus 5 multiply 7 10 to 3. Again, here I can write 4 multiply 7 by 10 to minus 5 plus 3 here. And we have 28 multiply 10 to minus 2. So as you can see, it's not necessary in multiplication and even division that the exponents be equal. Let's solve another problem in division. To divide using scientific notation, we divide n1 and n2 as an example. n1 and n2. As usual, and subtract the exponents. As an example here, 6.9 multiply 10 7 divided by 3 multiply 10 to minus 5. It can be written like that. 3 like by 10 7 minus 5. When the exponent goes up, the sign would be changed. It's a rule. So the final result is 2.3 multiply 10 to 12. Here I provided you two practices that I will solve them for you next session. See you later.